Our lesson on 6.8 is going to have us analyze graphs of polynomial functions. Now you're definitely going to need a graphing calculator to do this lesson and to do the homework and the quiz and the test questions associated with this lesson. So first we have a function 3x to the third minus 9x plus 1. So they're going to ask us to find x-intercepts, maxes, mins, and then intervals where it's increasing and decreasing. So the first thing I know is that I need my calculator. So I'm going to go to y equals, and I'm going to clear out the last function. I'm going to type in my new function. So 3x to the third minus 9x and then plus 1. Now when I hit graph, I'm going to notice 3 x-intercepts. There's one right here, there's one right here, and there's one right here. And you might think you know what some of them are, but remember your calculator has kind of cruddy pixels. So we're going to go ahead and make sure we use our calculator functions to find those x-intercepts. So remember, we go to second, trace, and then you choose number 2, which is called the zero finder. And you can only find one of the x-intercepts at a time, so I always start on the left one. I need to bring my cursor so that he's just a little bit to the left of this x-intercept. So I'm going to press the left arrow until I get just a little bit to the left of him, and once I'm there, I'm going to hit enter. And now it says right bound. He wants you to take your cursor and go a little bit to the right of that x-intercept. And then when it says guess, just hit enter one more time. And our x-intercept, like it normally is in Algebra 2, is not very pretty. So our first x-intercept is negative 1.79 actually. Okay, back to my calculator. Oops. We're going to do the same thing, and we're going to find the next x-intercept, which is right here. So second trace, we're going to find the 0, which is an x-intercept. Now I know he's technically to the left of him. I don't like him to be so far away, so I'm going to bring him a little bit closer, but still to the left. Hit enter. And then a little bit to the right of the x-intercept. Hit enter. And then enter one more time, and we get 0.112. Well, we can just say 0.11. I don't think it told me where to round, so I always do the hundredths if it doesn't tell me. And then our last x-intercept, we got to pull up the zero finder one more time. I know I'm already technically left of him, I just want to get a little closer. So I'm just a little bit to the left of him. Once I'm there, I'm going to hit enter. Basically what I'm doing is I'm just giving my calculator a smaller window to look at so he can do his calculus and be a little more exact than he normally would be. Now I'm glad my calculator did this. It's giving me my 0. You should notice that on my y value I get 1e negative 12. This is shown up before on our calculators. Remember, anytime it has an e with a negative exponent, this means 1 times 10 to the negative 12th. That's a teeny tiny decimal. That's 0.0000000000001, which I think we can all agree is really just a 0. And what's happening is the pixels on your calculator are not very great. So your calculator is doing really exact mathematics with a not so exact picture. So we're just going to have to chalk that up to pixel issues. So our other x-intercept is going to round to 1.67. Now while I'm here, I'm going to go ahead and plot those x-intercepts as best I can. I know they're not going to be exact. Okay. And now the next thing they want me to find are any maximum points. So if you looked at your graph on your calculator, a maximum would be when it bumps up, and I notice there's a maximum right there. So we're going to find that maximum by hitting second, trace, and then this time we're going to pull up the maximum finder. So now when it says left bound, they want you to drag your cursor so that you're just a little bit to the left of that maximum bump. So once you're there, hit enter. And then it asks you to go a little bit to the right of that maximum bump, hit enter. And then guess, you just have to be in the neighborhood, so hit enter one more time. And again, my calculator's having a bit of a pixelation issue, but I think we can all agree that I should round that to the point -1,7. They want the whole ordered pair here. You probably got an actual -1,7 instead of a rounded off, but that's okay. Pixel issue. So -1,7 is going to be our max right there. Let's do the same thing, except this time we're going to find the minimum. So you can see there's a little minimum point right there. Second trace. This time choose the minimum finder. And I know I'm already to the left of him, I just want to get a little bit closer. So I'm just slightly to the left of him, hit enter. And then slightly to the right, hit enter. And then enter one last time, and I get the point 1, -5. Okay. I have enough information here to go ahead and draw. Now, save your laughter for my graph here. Remember, oh geez, my graphs are never good. And these are exceptionally hard to graph on this tablet, so bear with me. Oh geez, okay. Okay, you know what? I don't think I'm going to be able to graph this. So, anyways, we're going to pretend like I graphed it, and you guys are going to actually graph it on your paper. But on your paper, your graph should look something like what's on your calculator, a nice little cube, not cube, but well, it is a cubic polynomial. Curvy, has arrows. Now, they ask us one more question. It says, tell me the intervals where this is increasing and where it is decreasing. So the intervals where this function is increasing, it would be nice if I had my graph on my actual graph paper, but I'll go back to my calculator, would be as you read it from left to right, where is it traveling upwards? So I notice it seems to be in an increasing, going up the roller coaster hill all the way until it gets to this point. And then it starts to decrease, goes down the roller coaster hill. And then it starts increasing again at that point. So I need to write these as intervals for my domain. So my domain, remember, is where it splits off in my x's. So for increasing, he starts increasing way over here at -infinity. And he keeps increasing until I get to the point x equals -1. Now, for increasing and decreasing intervals, you never use brackets because at the point, at the very top of the roller coaster or the very bottom, you're neither increasing nor decreasing. So you can't put a bracket there. Now remember how we said it started to decrease after that, and then it starts increasing later on? Since I need to jump, I need to put a union in the middle of this. And then the next time it starts to increase was when it was at x equals +1. And then it starts increasing forever and ever and ever. So the intervals of increasing on that polynomial are -infinity to -1, union 1 to infinity. Now that leaves us the other part for the decreasing. The only part that it was going downhill was in this part of the graph right here, here to here. So remember, that was from -1 to 1. So the increasing and decreasing interval stuff is a little complicated. Let's try some other examples and see how that is settling with you later on. So next, I need to go to my calculator and type in that function, because I really can't find most of these things without my calculator at this point in my math career. You just need some graphing help. There are other ways, and you'll learn all about them in calculus. So we have -1/4, x to the 4th, whoops, lost my caret, plus 2x squared. Okay, when I graph that, I notice it looks kind of like an upside down W graph, which is a quartic, and that makes sense. Now the x-intercepts. Technically, there's only 2 x-intercepts, right here and right here. And I know some people are going to argue that this point right here is an x-intercept. An x-intercept, a true x-intercept, is where the function crosses the x-axis. Well, it doesn't actually cross right here at 0. It bounces off, and that's because it has multiplicity. Remember a lesson ago, we talked about when solution showed up twice, it had multiplicity of 2, and it ended up just kind of bouncing off the x-axis. This is what it looks like. So I need you to find this x-intercept and this x-intercept. And what's kind of neat about this graph is because it has symmetry, once you find this one, he's just going to be the positive version of that. So we have half the work. So second trace, in order to find an x-intercept, you choose the 0 finder. And then bring me a little bit to the left of my x-intercept. Good enough. Hit enter. A little bit to the right. Whoops. enter, and then enter one last time, and we got negative 2.83. So what that tells me is I've got an x-intercept at negative 2.83, and I could tell from the symmetry the other one is at positive 2.83. And if you happen to tell me you had an x-intercept at 0, I'm not going to count you wrong in this class, but you're not technically right, so stop saying that. Let's go find our maximums. And notice I said maximums because we have a max here and we have a max here. Now again, there's some symmetry, so if you can find this guy, he's going to be the positive version of it over here. So second trace, maximum. I'm already to the left of the maximum, I just got a little bit closer, so once I'm there, hit enter. And then go a little bit to the right of the maximum. And my maximum is at the point negative 2, 4. Which tells me if this is negative 2, 4, then this guy has to be positive 2, 4. So we've got a max at negative 2, 4 and positive 2, 4. Oh, I haven't been graphing these. I guess I should. There's one intercept. There's the other intercept. Negative 2, 4. Positive 2, 4. Okay, and then a minimum. I think I know where he's at. He's at 0, 0. So I'm not even going to bother using my calculator to find him. He's obviously at 0, 0. Now again, okay, that one's not as bad to graph. Whew. Okay, pretend that looks good. Yours needs to look a lot better than mine. So intervals where this guy is increasing would be going up. So if I was looking at this as a roller coaster who started on the left and traveled to the right, my roller coaster would be going up from negative infinity all the way until he got to this point right here. I graphed that kind of bad. Sorry about that. So he's increasing right here, and then he's increasing again right here. So that goes from negative infinity to negative 2, and then he jumps, and he doesn't start increasing again until 0, and then stops increasing when he gets to 2. Now his decreasing part is right here and right here. So he's decreasing from negative 2 to 0, union, positive 2, and then he decreases forever after that. So in my eyes, it kind of helps if you color code the parts of your graph for increasing and decreasing, but if you can see it without coloring it in, that's fine too. Moving on. Okay, our next example, need my calculator, so let's grab it. Clear out the last problem. Type in my new ones. We have x to the 5th minus 5x to the 3rd. Whoops. Plus 4x. Oh my. Now there's a lot going on in that graph. I see 1, 2, 3, 4, 5 x-intercepts. Unfortunately, we actually have to find all of them. Now, the kind of good part, I'm thinking these are nice numbers. I'm just kind of looking at where they're crossing, and they look like they're whole numbers. For instance, I think this guy right here is a negative 2. Now, instead of going through all that second trace, zero finder stuff, if I think this is a negative 2, what I'm going to do is I'm going to hit the trace button, which pulls up the cursor, and then I'm just going to type negative 2. And then if I hit enter, if it tells me the y value is a 0, then I was right. He was an x-intercept. Okay, I was right. So let's write that one down, negative 2. Okay, we're going to do the same thing for this guy. I think he's a negative 1. So I'm just going to go ahead and, while the cursor's up, and type a negative 1. Oh, I was right again. I think this guy's a 0. So I'm going to type a 0, hit enter. Oh, right again. I'm thinking this guy's a 1. Man, I'm on fire. I think this guy's a 2. Now, this will only work if I think these are whole numbers. If they're not whole numbers, don't bother doing this method. So we had 5 x-intercepts. They're all pretty nice. We had negative 2, negative 1, 0, 1, and then 2. Yikes, there is no way I'm going to be able to graph this one. Hopefully you do a much better job than I'm doing here. Oof, those are very tight together x-intercepts. Now, the maximum, I don't think I'm going to be able to find that so easily on my own. And in fact, I see 1, 2 maximums. So second trace, I'm going to choose the maximum finder. And it doesn't matter which one you find first, so I'm just going to find the closest one to me. I'm going to go a little bit to the left of him, hit enter, and then a little bit to the right of that maximum bump, hit enter, and looks like he's at 0.54, 1.42. Let's write that down before I forget that. Alright, back to my graph. I'm going to find this other maximum. You've got to pull up the maximum finder again. And then this time, you just scroll a little bit to the left of, whoops, too far, to the left of him, hit enter. And then just a teensy bit to the right, enter. And then enter one last time. So his maximum is negative 1.64, 3.63. Okay, let's take a minute and let's go ahead and graph these. Yikes. 1.42, so like roughly right there. And again, a little hard to graph these decimals, so just do the best you can. Now, back to the graph for minimums, because there's no way I can do this without my calculator. I see 1, 2 minimum points. So let's do second trace. Let's choose minimum. And I think we're going to find a sort of symmetry. Okay, I'm just a little bit to the left of that first minimum. I'm going to hit enter. And then a little bit to the right, hit enter. And then enter one last time. And I don't know about you, but I'm sensing a bit of symmetry here. So we have a minimum of negative 0.54, negative 1.42. And if you just kind of think about how the symmetry worked here, I think it would be smart of us to assume that this minimum right here is going to be a 1.64 and a negative 3.63, and he is. So if you don't trust me, go ahead and find it yourself. But he's a 1.64, negative 3.63. So if I try to graph those, so do the best you can. Now, this is going to be terrible for me to try to graph, so I'm not even going to bother, but I need you to try to connect these and make this very strange little quintic graph. And the basic idea is you want it to look like what's on your calculator. Whoops, what was on my calculator. So it might be easier to connect the little bumps in the middle before you do the ends. Take a minute to do that. Okay. So we next need to determine the intervals on which this function is increasing and decreasing. So when I look at the parts where it's increasing, it was increasing from negative infinity until it got to this point right here, this maximum. So like that whole section. And then it started increasing again from here to here. So from here to here, and then here to here, and then it went back to decreasing, and then from here to here, it was increasing again. So if I was going to write those as intervals, I would say it starts at negative infinity, and then once it reached negative, what was that, negative 1.64, it stopped increasing. And it didn't pick up increasing until it got back to negative 0.54. Oh, that was 0.54. Sorry, not 5.4. And then it increased until it got to positive 0.54. And then it stopped increasing for a minute, and then it increased again once it got to 1.64, and then continued to increase for the rest of its little polynomial career. Now the decreasing sections were between here and here, and between here and here. So if I try to label those, I started decreasing at negative 1.64, and then stopped decreasing when he got to negative 0.54. And then he picked up again at 0.54, and then stopped decreasing once he reached 1.64. So the symmetry almost made the intervals a little confusing because you had positive and negative of everybody. But again, I am a strong believer in using colors on these. I think it's easy to determine increasing and decreasing if you use your colors. So next, I'm going to give you a function, and it's in what we call factored form. Since it's in factored form, I can tell you where your zeros are really, really, really easily. So if I look at my factors, here's one, here's one, and here's one. That means we've got an x-intercept at 2, we've got one at -1, and we've got one at -3. So I'm going to go ahead and graph that. There's one at 2, there's one at -1, and there's one at -3. Now to get the rest of this function, I'm just going to use my graphing calculator to determine where my max or mins need to go. So let's pull up our calculator, clear out the last problem, and we're going to type 1/5, so 1 divided by 5, x minus 2, x plus 1, oops, lost my parenthesis there, and then x plus 3. So it won't be too hard for me to find this max and this min. If I do second trace, let's find the max first just because I feel like it. Go a little bit to the left, a little bit to the right, enter, and enter. He's at -2.12.81. Okay. So again, you're going to do the best you can. -2 and a little more. So like, he's roughly right there. And then I want you to be a little bit accurate on your homework. I need you to find this minimum now. So second trace, minimum. A little bit to the left. A little bit, oops, a little bit to the right. He's at 0.79, -1.64. So again, decimals not so easy to graph here, just do the best you can. And then, oh, you know me. Oh geez, that's really bad. Make your graph look a lot better than mine. So it looks something like that. Now if I asked you to find domain or range, intervals of increasing or decreasing, all those things would be very, very easy to do once we knew our max and our min, because those are called our turning points. Alright, same idea here. It's in factored form, except this time we're going to run into something called multiplicity. Now we can easily see that we've got one of the solutions at 3 and one of the solutions at -1. But notice how they show up twice. So we've got, they bounce off the x-axis at points x equals 3. And I'm going to write a little note to myself. It's got multiplicity of 2. And then it also will bounce off at x equals -1. It's going to bounce because it also has multiplicity of 2. So anytime you end up with multiplicity that it's an even number of times, so it shows up twice or 4 times or 6 times, the graph is actually going to bounce off the x-axis at that point. So I'm still going to draw a point at x equals 3 and -1, but I just have to remind myself that when I graph this, instead of crossing, he's going to simply bounce off like he's a rubber ball. So let's go to our graphing calculator and verify that that is what happens. So back to y equals, type in your new function, 1/2 quantity x minus 3, close the parenthesis and then square it, and then quantity x plus 1, close the parenthesis and then square it, and you're going to see that surely enough it bounces off at x equals -1 and x equals +3. So the only thing I think I'm going to find to just make sure I graph this accurately is this little maximum bump, because I can already tell you where the minimums are. They're the supposed x-intercepts. So we got a max. Okay, a little bit to the left, enter. A little bit to the right. We've got a max at 1/8. So, okay. Oh, geez. My goodness. It's just getting worse and worse. So you are going to do a much, much better job than I am doing with my graph. Oh my goodness. Yuck. Ugly, ugly, ugly. Alright. Do a much better job than I just did. You're going to have a graph, looks kind of like a W, and that's what it should look like when you encounter even multiplicity. It'll bounce right off. Definitely need your calculator handy when you're trying to do this homework. If you're at home and you don't have your own calculator, you can go online and just Google graphing calculator, and you will find many, many applications online that are free that can do all of this for you, just like my classroom calculators can. So no excuses. Get that homework done.